thought that was my multiplication there, because I didn't realize most of these I had were 21.
So you want to send
But whatever. No, I never thought that would be bad multiplication.
Okay, in your notes booklet. So yesterday we did some notes and then we didn't do a couple here.
Yeah.
So this is in your notes. And we did not do example 5 or 6, so we're going to do those today. Okay.
I mean, you did the 5 kids either, so.
So this is a binomial, this is another binomial. What is the system that you have to do when you have two binomials? FOIL. Okay. First times first. So the whole number is 25 root 9. Outsides. Whole number 5 radical 21. And that's a minus. Insides. Whole number plus 5 root 21. Last subtract root 49. Okay. Anybody know what happens here? It cancels out. It makes 0, right? What could I do differently with a root 9?
3.
I could say that's a whole number 3, which makes this 25 times 3, 75. Root 49 could turn into a 7. So my final answer? 68. Okay, so we're going to be using this strategy a few times later here. Do you see this and this? They are the conjugates of each other. I'm going to be using that word. Okay, so what do you notice about when you look at this and you look at this? What do you notice about them?
They're practically the same, but one's adding, one's subtracting.
They're the same except for one will be a plus and one will be a minus. What do you think is going to happen when I have conjugates? When I recognize it, I'm going to cheat. Instead of foiling, I'm going to flood. Because that O and that I should always cancel out if they are true conjugates of each other.
So if sorry, can you say the definition of a conjugate again?
It's like the same, but one would be a plus and one would be a minus.
Right, okay.
It's also the same idea as a difference of squares, right? This is a difference of squares. Do you see it? This and this are the same, but one's a plus and one's a minus. First times first is x squared. Outsides make plus 3x. Insides make negative 3x. And the last makes negative 9. Then what? Those are gone. That's why the difference of squares has no middle term. The O and the I get canceled out. Okay, so that's a conjugate. Number 6. What do you think I'm going to do in math when I see something gets squared?
You get square root, square everything. Now.
So squaring, I heard, was the idea of multiplying something, repeat it. Is this a conjugate? No, it's not. So I can't cheat. I have to do all 4 parts. Okay. First times first is root 25. If some of you are getting good at this idea, when you have a root times itself, it just cancels and becomes the whole number 5.
So you can just write 5 instead then?
Because that times that is root 25. If you were understanding that idea, I would have been fine if you just wrote the whole number 5. What do you have on the outside? 4 root 50. What do you have on the inside? 4 root 50 plus the last 16 root 100. Okay, so we turn that into a 5. What do you want to do here? Add them together. So 8 root 50s. 16 times root 100. Can you work with that?
That would be 160.
16 times the whole number 10. So plus 160. So 165 plus 8 root 50. But I'm actually not done.
Do you want to make that thing smallest as possible?
If I'm making them small as possible, what can I break 50 down into?
Root 25 and root 2. This with some of them, but not all.
Okay, so then that becomes okay. Yeah. Was there a question? Good?
I do know when you're supposed to do the last part there.
So if you had a root 14, like 14, is it divisible by 9, 16? No.
So we can always be checking.
Yeah, you always check in your head, does it divide by 4, 9, 25, 16, 49, right?
Okay.
Okay, we're going to keep going here. Rationalize the denominator. So the denominator is which part of the fraction? The bottom. Okay, so in math, it's not proper to write a number with the radical in the bottom. Okay, so what I'm going to do is I'm going to look here and I say I have a root 3 on the bottom. So I'm going to times it by another root 3. But if I do that to the bottom, what should I also do to the top? The same thing. Okay, here's the idea. What did I essentially times this by?
Root 3.
What is this, the number? 1. It's a 1. If I times something by 1, do I change the value of it? No. So I'm not changing the value of anything because I'm timesing by a 1. Okay, what is the top? 7 root 3. What do you get when you do a root 3 times a root 3?
You get root 9, so 3.
You get root 9, which is a whole number 3. And look at my answer. I have a number without a radical situation in the bottom. Okay. Next, so I don't want the root 2 on the bottom. So I'm going to be timesing by a root 2. But I also have to do it to both parts. So the top is going to be 8 root 10. And then what do you get when you have a root 2 and a root 2? Becomes the whole number 2. So you can think of it as root 2 squared, which becomes the whole number 2, or you could think about it as the root 4, which turns into 2, right? Either way. Okay, I'm not done here. There's more things I can do to this, though. Anybody see something I could work with yet?
Divide both ends by 2.
Reducing the 8 and the 2, so this would become 4 root 10. Okay. Next, there's a root 5 on the bottom that I don't like. So I'm going to times it by root 5. Okay, do you notice how I'm not worried about the 4 part of it? I'm just going to times by the radical part of it. Okay, so the top would be root 15. And the bottom is 4. And then if you want to do root 25, or if you want to just do whole number 5, it's depending on where you're at. But then I need to understand that that would become eventually a 5. So now my bottom will be 20. Okay, and the final answer, you better not have any kind of radical in the bottom when you're done. That's the goal of it. Okay, do you understand I can't reduce? Here I can't reduce. If you were thinking about reducing, you can't, because you can't mix. Can't mix. Radicals and whole numbers can't be mixed together. Okay?
Yeah, I didn't want too much.
All right. Now, the last 2 examples are different. This time, my bottom is a binomial. Okay, so did you see on these? This had 1 term, 1 term. This was 1 term. So now I have 2 terms on the bottom. So this is where we do the word conjugate. What is the conjugate of this binomial?
Root 2.
So we talked about it, that it looks the same, but we need to have a plus and a minus sign. They have to have opposite signs of each other to make that cancel happen. Okay, whatever we're doing on the bottom, we're doing to the top. Okay, so on the top, we're going to need to multiply like this on the top, right? That would cause a distribution. We've practiced that. So root 70 minus root 14. Okay, on the bottom, what is the special thing about your FOIL situation? Those you don't have to do. You can do them, but you'll just notice that they always make 0. So first times first makes square root 100. And I'm okay if you just write 10 right away. Last times last is always going to be what kind of sign? Always subtract, always, because one's a plus, one's a minus. Last times last is root 4, or whole number 2. So you could write it in 2 stages, or if you want to write it in 1, I don't care. So what is the bottom value? 8.
Do we do anything?
So I'm just going to check out 70. Is 70 divisible by 4? Nope. Is it divisible by 9? Nope. Is it divisible by 16? Is it divisible by 25? No. What about 14? Is it divisible by any of those? No. So I'm done. Okay, number 5. So this is a binomial bottom. So what is the conjugate of that? 2 root 5.
Subtract 3 root 2.
Okay, so repeat it, but make sure your sign changes. So if I had to subtract, you would have had an add, right? And vice versa. Okay, what should we do to the top stuff here? I think we have to FOIL it. Sorry, there's no shortcuts there. We gotta FOIL. Okay, here we go. First, 4 root 15. Outsides. It's a subtract. 6 root 6. Insides.
235.
Plus 2 root 35. Last, subtract 3 root 14. Okay, on the bottom I can do some cheating though, because my FOIL system, I can just flood, because I know those are canceling. Okay, so first times first makes 4 root 25, which would be 4 times whole number 5, which would be 20. Always a subtract, because there's going to be a plus and a minus. So the last times the last makes 9 root 4. 9 root 4, which is a 9 and a 2, which is 18. So what is the actual number I would end up with on the bottom? 2. And the goal was to make sure we end up with no radicals on the bottom.